Hey everyone, in this video I solved LeetCode question 15, 3-sum. Given an array of integers, identify all of the unique triplets that when summed give a sum of 0. So I've noticed that some of the Python submissions for this question result in time limit exceeded. And here's a submission that actually passes that time constraint. I think something to really watch out for here is storing your triplets in a set as opposed to a list, because a list requires O of n lookup time and a set requires O of 1 lookup time, and that might factor into why certain solutions result in time limit exceeded. Alright, so let's get started. So to start out with, we want a set to store the triplets that we have found so far. In range lines, and since we actually don't, we can just do -1. So something that if you think about, if you have one number in the triplet as your first triplet number, then that means the two other numbers in the triplet must be, when summed, must be the opposite of that number, such that when they are added, it results in 0. So to solve the 3-sum problem, we actually just need to solve the 2-sum problem for the for numbers 2 and 3 in the triplet. So if we designate a target value as just the current number but reversed or opposite, 2-sum result equals. So here we actually need to we'll write the 2-sum function later, but for now we need let's just write it top down. We need to pass in our nums. We need to pass in a pointer, and since our current pointer is for nums, to find all the other numbers, we need to start looking from i+1. Alright, so what we're going to pass here right now and just start working on our 2-sum function. So as mentioned, target. Alright, so for the 2-sum, we also need a set. Let's just call it aux for auxiliary. And then our output set. So if the target minus the current num in the 2-sum exists in the auxiliary set, we add a tuple consisting of that current num and the target minus num. Else we simply just add the current num to the auxiliary set, and then at the end we return the output set. And so here our 2-sum result may actually have multiple results. And so for result in 2-sum result, our triplet is a be consisting of nums I, result 0, and result 1 for whatever result in the two-sum result. And we want to keep it sorted so we have an easier time checking to see if this exists in triplets. Sorted. And then turn it into a tuple to be able to put it in triplets. T top equals tuple T if T top in not in triplets, then you just add it to the triplets. All right, and then at the end you return triplets. All right, let's run it. What happened here? Typo. Nums. Accepted. All right, let's submit it and check. All right, so it passes, and so with the use of a triplets set as opposed to a list, we're able to actually get a better runtime. All right, I hope this helps. See you next time.